All right, we are back with question 9. Hydrogen cyanide. What's going on here? I'm just going to get the pen out. I feel like I should explore with the different colors one of these days. All right, we're going to start by reading and hopefully understanding every word in the question. So hydrogen cyanide is a highly poisonous gas. I feel like people have heard of the term cyanide in some other context and associate it with toxic anyway. The lethal dose for human is 300 milligrams per kilogram of air. So this is going to be 300 milligrams of hydrogen cyanide. So the mass of hydrogen cyanide per kilogram of air. Effectively, this is a concentration of hydrogen cyanide in the air that will be lethal. Hydrogen cyanide can be produced by the following reaction. Okay, so we have sodium cyanide with sulfuric acid. This is an acid reacting with a salt, and then you get sodium sulfate and hydrogen cyanide releasing as a gas. So this is also a gas, which is quite interesting for an ionic compound. All right, I'm not sure where we're going to go with this equation, so I'm just going to continue by reading part A. If the air density at 26 Celsius degree and 101.3 kilopascal is 0.00118 grams per mil, so we'll talk about density here, and this is density of the air. All right, density is a ratio between mass and volume. And another piece of information that also tells you that is the unit of density, which is gram. Now, to the power of -1 is the same as per mil. So effectively, this is gram per mil. So mass, grams is a unit for mass divided by volume, which milliliter is a unit for volume. All right, the air density is this. What mass of HCN would be present per mil? I'm going to assume this is per mil of air at the lethal dose. Wow, that's exciting. Okay, let's go back. I'm gonna just ignore part B for the time being and just focus on part A of the question. I don't think I need to use this equation just yet because by the look of it, there is no indication in part A, there's no indication in this question so far that there is a chemical reaction happening or that I need to calculate the amount of any of the reactant or any of the product involved in the reaction. The only thing that this question has to do with is air. It's air density, and then there is what I'm assuming to be per milliliter of air. If you read the sentence properly, the air density is this, what mass we present per mil. So that should be of air. Now, if you go back to the question, they tell you, oh, and then obviously is lethal dose. All right, so the lethal dose is 300 milligrams of HCN in 1 kilograms of air. All right, we are then given, I'm just focusing on part A at the moment. We are then given air density. So I know for air, if I have the mass per volume ratio, so the mass per volume ratio of air is 0.00118 grams for every milliliter of air. You know that the temperature is 26 Celsius degree, and you know that the pressure is 101.3 kilopascal. Now, you are allowed to use the universal gas law for hydrogen cyanide because it is a gas. I don't think you would be allowed to use the universal gas law for air because it's not a pure gas. It's a mixture of different gases. So I can use PV equal to nRT for hydrogen cyanide since it is a gas. That's always good to know. What else do I have? Yes, well, I think that's all that I'm given. I need to find the mass. I need to find the mass. Why do I need... Okay, I need to find the mass of hydrogen cyanide present per mole of air. Now, so this question seems really easy. Maybe it is easier than what I thought it would be. Okay, never mind. Let's just get a new page and think about what we need to do. So if we need mass of HCN per 1 ml of air, essentially this is what you need to find. You know the relationship between the mass of hydrogen cyanide per 1 kilograms of air. So what you need to do is you need to be able to convert mass of air into volume of air, and then you should be able to work out the amount of HCN per mil. I generally do this in one step. Let's see whether I could break it out. So the first thing I'm going to do is I'm going to find the volume of air in, well, 1 kilograms of air. All right, and this is where the air density is going to be useful. So it will go unknown over given, then every mole of air has the mass of 0.00118 grams, if that's, yep. So if I have 1 kilograms, now you definitely need to convert kilograms to gram here so that the unit is consistent. If I have 1 kilograms of air or 1,000 grams, you should be able to work out the equivalent volume. So V is going to be 1 over 0.00118 times 1,000, which is, I'm just typing into the calculator here, 0.00118 is a massive amount. I got 80, well, it's in mil, maybe that's why. 7457.627 milliliter. So 1 kilograms of air is equivalent to 847,457 point something milliliter of air. Okay, now which means that if I have, so this is step 2, I'm gonna try to do this. If I have 300 milligrams of hydrogen cyanide, this is a lethal dose, in 1 kilograms of air, it's going to be equivalent to 300 milligrams of hydrogen cyanide in this many milliliter of air. So 847.627 milliliter of air. And using this ratio, you should be able to work out the mass of hydrogen cyanide in 1 milliliter of air of the lethal dose. So we just need to rearrange. So mass of HCN, I really don't want to write that number again, but that's fine. So 847,457 times 0.627 times 1. Obviously, you don't have to do this step, but just to show you where, when the ratio is not, when it's not 1, as a denominator, what you would do now, you get a very small number. I get 0.0, I'm going to go 3.54. How many sig am I after? Okay, if you look at the actual value that you use, you have 300 milligrams and it's 3 sig, and then the 118 is also 3 sig. Even though there's a 26 degrees Celsius here, you don't actually use it, so you don't count it as part of the significant figure. So I get 3.54 times 10 to the 1, 2, 3, 4, negative 4 milligrams. That's my answer for part A. I think the issue with this question that people probably will have is that you don't actually have to use the information regarding temperature and pressure, which I didn't know when I read the question. And if you don't, that's fine too. I mean, it's still a good idea to keep it keep in mind that you can use PV equal to nRT because HCN is a gas. You actually didn't have to, and that's okay. The other thing that you didn't have to use was the equation given to you at the start. I guess that's going to come in for part B. So it's very important to keep a clear head. Most of the time you have to use all the values given, but sometimes you don't have to, and if it doesn't fit, don't try to use it. I mean, I couldn't really imagine how you're going to use PV equal to nRT in this case anyway, because, well, I was thinking that if they give you the volume of hydrogen cyanide, you can find the number of mole and then the mass, but they didn't do that, so there is no way you could use the universal gas equation. Just don't feel obliged to use every single value, especially if you already have another way of doing the question. Anyhow, let's see. Oh yeah, there's no way I can fit this in, so I'm just going to get another slide before I continue. Okay, and obviously I have to get the pointer again. So we're gonna read part B, and hopefully we get to use the equation at this point. Otherwise, I would be a little bit concerned because like why would you give the equation? Okay, if 8.8 grams, yeah, very good. So you have sodium cyanide is added to 100 ml of 0.475 mole per liter of sulfuric acid, what volume of hydrogen cyanide gas is produced at 100 kilopascal and 20 Celsius degree? This is a very, well, I wouldn't say classic, but it's not too difficult of a question. So we're just gonna rewrite the equation, I think. So 2Na, that's not NaCN, which is a gas, which is quite interesting, aqueous. So you get Na2SO4 and HCN. Put 2 here. This is gas, this is AQ. Right, I think 8.8 grams. So the mass of sodium cyanide given is 8.8 grams, and you also given information regarding concentration and volume of sulfuric acid, 100 ml at 0.475 molar. So V of H2SO4 is 100 ml with a concentration of 0.475 molar. You need to find the volume of hydrogen cyanide produced given a pressure of 100 kilopascal and temperature 25, 23, 20 Celsius degree, which I'm going to go ahead and convert to Kelvin because I think I'm going to use the universal gas law in this question. Now, if you think about what the universal gas law is, which is PV equal to nRT, and you are allowed to apply it for hydrogen cyanide for it being a gas, and we're assuming ideal behavior here. In that case, if I can find, well, V is going to be nRT divided by P for R being the universal gas constant, which is 8.31, which means that if I can find the number of mole of hydrogen cyanide, I should be able to find its volume. And in order to find the number of mole of hydrogen cyanide, it being a product of this chemical reaction, I need to determine which reactant is the limiting reagent and then use the mole ratio of that reactant and use the number of mole of that reactant and the mole ratio in the equation to determine the number of mole of hydrogen cyanide. So I think the first thing I'm going to do is I'm going to determine the reactant that is limiting. Find the reactant that is limiting, or find the limiting reactant or the limiting reagent. Before you do that, you can't really use the mole ratio, because if you look at this, you are given some quantities for both reactants. So the question is, which one are you going to find the number of mole of to get to the product? And the answer is you have to find the number of mole of both of them and work out which one is actually limiting. So I'm going to find the number of moles of sodium cyanide, which is going to be mass divided by molar mass. I don't actually know what the molar mass of that is, so I'm going to work it out. Something or other. 8.8 is the mass, so 23 for sodium, 12 and 14. So we get 0.1796 or so mole. So that's the number of moles sodium cyanide. Now, if you work out the number of mole sulfuric acid, they give you volume in mil. So I'm going to convert it to liter, and concentration. So N equal to CV, I will get 0.0. That's not good. Okay, 0.0475 mole. Okay, so I've got the number of mole of both substances. The theoretical mole ratio is 2 to 1 between sodium cyanide. Am I going to get enough room? Sorry, I'm just going to try to change this a little bit. 0.179592 mole. Just trying to create a little bit more room because I really don't want to start with another page. 475 mole. This is the issue with using PowerPoint, I think. Okay. Anyhow, so there are many ways to determine limiting excess, even though kind of look like, actually I don't know, 0.02. Yeah, kind of look like sulfuric acid is the limiting reagent. But if you, well, one way to determine it is to compare the theoretical versus the actual ratio. So we're going with N of NaCl, sorry, NaCN, sodium cyanide, over number of mole of H2SO4. The theoretical ratio, which this is just one of its many names, is basically the ratio that you get from the equation, and the equation gives you a 1 to 2 to 1 ratio based on the coefficients. The actual ratio uses the actual amount given to you from your calculation. So I have 0.179592 over 0.0475. Now, if you want to actually make a comparison, you're probably better off. Maybe I got that wrong actually. I don't know what I'm saying. 0.0475. Don't worry. So this is a 3.78 over 1. Okay, so theoretically speaking, for every mole of sulfuric acid, you need 2 mole of sodium cyanide to completely react with it. In reality, for every mole of sulfuric acid, you actually get 3.78. So you have more sodium cyanide than the amount required, which means sodium cyanide is in excess. So H2SO4 is indeed the limiting reagent. I did get that right. I thought I got it wrong for a second. Is the limiting reagent. Once you know it is a limiting reagent, you should be able to determine the number of mole of hydrogen cyanide, which is a product, using the number of mole of the limiting reagent, in this case being sulfuric acid. So the mole ratio from the equation, again, in this time is a 2 to 1 ratio, similar to the previous ratio, which means that N of HCN is going to be 2 times N of H2SO4. Fortunately, I think I do need to get another slide. Okay, so 0.0475, we're just going to double that, and we get 0.095. Why does this happen to me? Right, so yes, I want to keep that, and I want to insert a new slide, and here we go again. There has to be a quicker way to do this. I just haven't investigated. I wouldn't say I haven't figured it out, because I haven't actually tried to figure it out at all. Alright, so that's the number of mole. Now, once we have the number of mole of hydrogen cyanide, we should be able to find its volume. So HCN is nRT. That doesn't look like an N. Let's try again. nRT over P. So 0.095 multiplied with 8.31 and 293, I believe. Temperature in Kelvin, pressure of 100 kilopascal. Okay, so it'd be very funny if, like, oh, this is wrong. Volume is around 2.3. I'm just gonna go back. So 2 sig fig, 263, yep, we're going with 2 sig fig for the final answer based on the mass, 2.3, and also the temperature. 2.3 unit will be liter using universal gas law. And that's the end of this question. And I need to stop recording.